Jai Hind students. In the previous session we have discussed about acceleration due to gravity, the factors on which the value of acceleration due to gravity depends, and thereafter we have discussed various numericals based on force of gravitation and gravity, right? So in this section students, we will discuss about mass, about weight, the essential points of difference between mass and weight, and then obviously the topic won't get completed until and unless we do numericals related to that topic. So after the completion of mass and weight, we will be discussing these few numericals related to mass and weight, right? So let's begin with mass and weight. Now students, look, mass must be a familiar term. In the laws of motion, we have discussed mass in detail. Now, theoretically, you are aware, all the bodies in this universe, they are made up of matter, and every matter is composed of atoms, molecules. Each atom consists of a central positive core, which is known as nucleus. Nucleus in turn consists of protons and neutrons. And nucleus is surrounded by negatively charged electrons. That is the composition of an atom. And several atoms, several molecules collectively makes a body, isn't it? So what I mean to say is that mass of a body is defined as the amount of matter contained in that body. So total amount of matter contained in a body is known as its mass. So students, the definition of mass would be amount of matter contained in a body. It is the amount of matter contained in a body. That is known as the mass of the body. Clear, students? Well, on the other hand, weight. Students, we are aware, Earth attracts every other body towards itself. Now, whichever object is placed on the Earth's surface or near it, it gets attracted towards the center of the earth. So, weight of a body is the force of gravitation exerted by earth on the body. That is actually the weight of the body. So, weight is basically the force of gravitation which is experienced by the body due to the earth. So, weight is the force of gravitation. It is the force of gravitation. It is the force of gravitation due to earth. So weight of a body is the force with which a body gets attracted towards the center of the earth. That is known as weight. Now here I must mention from Newton's second law, we are aware F is equal to mass into acceleration. Now suppose this is the earth and this is the mass of the earth, and this any body placed on its surface, its mass is small n, right? So in this case, this body under the influence of gravitational force due to the earth, it will experience a force. This is the gravitational force, isn't it? And this net external force is also given by m into a. Now under the influence of force of gravitation, the body will experience an acceleration, and that acceleration, students, we have already discussed, it's known as acceleration due to gravity. So in case this F is force of gravitation, then A gets replaced by small g, which is the acceleration due to gravity. And student, this force of gravitation which the body experiences under the influence of this earth, that is known as the weight of the body. So weight of a body is actually the force. So it may be represented by W. So weight of a body is given by M into G. So remember, weight of a body is given by the product of the mass of the body and the acceleration due to gravity at that particular point, right, where the weight of the body is supposed to be measured. So weight is a force. Again, let me repeat it. Mass of a body is the total net amount of matter contained in the body, while weight of a body is the force with which the body gets attracted towards the center of the earth. right? It's the force of gravitation exerted by the earth on the body. That is the weight of the body, right? So weight of a body mathematically is given by the product of mass of the body and the acceleration due to gravity. Clear, students? Okay. Second point. Again, we have discussed in detail about inertia. Inertia of rest, inertia of motion, inertia of direction. So, we have discussed in detail about the term inertia. And students, you are aware, the greater the mass of the body, the more is the inertness of that particular body. The lighter the body, the lesser the amount of matter contained in the body, the smaller is the inertness of the body, isn't it? So what I mean to say is that mass of a body gives the measure of inertness of the body. So mass, it gives the measure of inertness of the body. How much inert a body is, that can be measured by knowing its mass. Greater the mass, more will be the inertness of the body, and vice versa, right? While on the other hand, weight, it's a force. So it gives a measure of force of gravitation experienced by the body due to the earth. So it gives the measure of force of gravitation. It gives the measure of force of gravitation. Weight is actually a force. Okay, third one. Mass, students, you are aware, it possesses only magnitude but no direction. So it is a scalar quantity. Mass is a scalar quantity. While on the other hand, weight, it has got both magnitude as well as direction. So it is a vector quantity. It is a vector quantity. Now look, this is Earth. So if a body is placed over here, this is the center. So the weight will be directed along the radius towards the center of the Earth. This is where the weight of the body will act. Let the body be placed over here. In this case, the weight of the body will always act along the radius towards the center of the Earth. If a body is placed over here, then the weight of the body will always act along the radius of the Earth towards its center. So weight of a body, it's a force, it's a vector quantity. It has got both magnitude as well as direction. What is the direction of weight of a body? It is always along the radius of the Earth towards the center of the Earth. So weight has got both magnitude as well as direction, and that is the reason why weight is a vector quantity. Fourth, mass is constant. Mass of a body won't change from place to place. Whether you take a body on lunar surface or Martian surface or any other planet or anywhere in the universe, the total amount of matter contained in the body will be constant. So mass of a body is constant, right? But on the other hand, the weight of a body is not constant. Why it is not constant? Because weight is equal to mg. And students, you must remember the acceleration due to gravity, that is small g. It is different at different places. At poles it is maximum, at equator it has smaller value. Then the value of small g decreases with the increase in the height. It also decreases with the increase in the depth, and eventually, ultimately, at the center of the Earth, small g becomes 0. So always remember, since weight of a body depends upon the acceleration due to gravity, therefore, weight of a body at different places is different. Like at the center of the Earth, g is 0. Therefore, weight of any body at the center of the Earth would be 0, right? So, since g at the center is 0, therefore weight of any body at the center of the Earth would be also 0. Clear, students? Weight of any body at the center of the Earth would be 0. Small g, its value on moon, lunar surface is 1/6. So therefore, weight of any body taken on the moon would be 1/6 of its weight on the Earth's surface. So mass of a body remains constant, But weight of a body which depends on the value of acceleration due to gravity, it will vary, it will be different at different places. At a place where g is maximum, weight of a body will also be maximum. At a place where the value of small g is minimum, the weight of the body at that place would be minimum. Right? So this is an essential point of difference between mass and weight. Fifth, it is independent of the presence of any other body. It is independent of the presence of other bodies. As I stated, mass is the total amount of matter contained. So in case it is placed or it is surrounded by some other bodies, still the amount of matter contained in the body will remain same. So as a result, mass of a body is independent of the presence of any other bodies around its vicinity or around its surroundings. Right? While on the other hand, students, weight of a body does depend upon the presence of other bodies around its vicinity. Understood? So, weight of a body does depend on the presence of other bodies. The net force will get changed, and weight actually is the force. So under the influence of some other bodies, the net force acting on a given particular body may get changed. So accordingly, the weight of the body might get influenced. So it does depend, weight of a body does depend upon the presence of other bodies around it. Right? Okay. Sixth point. Now as you are aware, mass is a scalar quantity. It is the amount of matter contained in the body. Every body is made up of matter, isn't it? So mass can't be zero. So mass of a body, it can't be zero. It can never be zero. While on the other hand, students, at the center of the earth, I have told you, the acceleration due to gravity at the center of the earth is zero. So weight of the body, weight of any body for that matter, at the center of the earth is also zero. So weight of a body can be zero. Weight can be zero. Mass can never be zero, but weight of a body can be zero. And students, another important point. Mass, as I have stated, it is the amount of matter contained. Its SI unit is kg. Right? While weight, it's the force of gravitation. So its SI unit is Newton. CGS unit of mass is gram. CGS unit of weight is dyne. So students, these are some essential points of difference between mass and weight. And I'm pretty sure after going through this theoretical concept, we are in a position to solve those questions. Right? So now let's try attempting those numericals based on mass and weight. Right? So let's start with the first question. Okay. First question is, mass of an object is 10 kg. What is its weight on the earth? Then what is its weight on the moon? And what will be the mass of the object on the lunar surface, on the moon's surface, right? So, mass of the body is given to be 10 kg. Now first part, weight on the earth. Now formula for the weight is m into g. Now we are considering weight of the body on the earth, then this must be the acceleration due to gravity on the earth's surface. So what is mass? 10. What is the value of small g on the earth's surface? It is considered to be 9.81 or 9.8. So 9.8. So it will be equal to 98. And what is the unit of weight? That is Newton. So this is the weight of the body on the earth's surface. Now let's find out the weight of the same body on the moon. Second part. Weight of the body on the moon. So it will be equal to m into acceleration due to gravity on the moon. It will be equal to m. Students, we have already mathematically derived that g moon is equal to 1 by 6, the value of acceleration due to gravity on the earth's surface. So what do you get is mg by 6. So mg is weight. So whatever is the weight of the body on the earth's surface, on the moon's surface, the weight will become 1 by 6. So weight of the body on the moon, it would be equal to 1 by 6 the weight of the body on the earth, that is 90. So it can be easily solved. So 16.33 Newton, right? So the weight of a body gets reduced by 1 by 6 times on the moon surface as compared to that on the earth. Clear, students? Third part. What will be the mass of the object on the lunar surface? Mass. Just now we have discussed, students. Mass is the total amount of matter contained. It won't change whether you take the body to any part of the universe, its mass will remain constant. So mass of the body always remains constant. Therefore, mass of the body even on the moon is or will remain 10 kg only. I hope you have understood the concept, students. So, question number 1 is done. Now let's concentrate on question number 2. A body weighs 90 Newton. The unit of weight is Newton on the surface of Earth. How much will it weigh on the surface of Mars, whose mass is 1 by 9 and radius is half that of the Earth? Right? So what to do is, it's given weight on the Earth. It is m into g on the Earth, and it is given to be 90. This is the given information. Clear, students? Now what to do is, we need to find out weight of the same body on Mars. Mass of the body will remain same, but value of g will get changed. G mass. So m, what is g mass? It will be g mass of the mass divided by r square. This is the radius of the Mars. Right? Because as we are aware, what is the value of g? It is g m by r square. If r is the radius of the Earth, m is the mass of the Earth, then small g would be the acceleration due to gravity on the Earth's surface. On the mass, the value of small g would be given by g m mass divided by square of the radius of the mass. Right? Now let's get the answer. M g mass, the mass of the mass, it is given to be 1 by 9th of the mass of the Earth. Radius, it's given to be 1 by 2, so it will be r by 2 square. So what we get is, if you solve it, so we get 4 by 9, isn't it? M, and then we get gm divided by r square. Gm by r square, that's the value of acceleration due to gravity on the Earth's surface. So what we get is 4 by 9 of mg. That is, weight of the body on the Mars is equal to 4 by 9 times mg. It is the weight of the body on the Earth. So let's substitute the value. So it will be 4 by 9 multiplied by weight of the body on the Earth is 90 Newton. So what do we get? 40 Newton. This will be the answer. Clear, friends? So this is how we need to proceed. So in order to calculate the weight of a given body, you need to find out the value of acceleration due to gravity at that particular place. Right? And small g is given by gm divided by r square. Clear, friends? So the weight of the body, whose weight is 90 Newton on the surface of the Earth, when taken on Mars, it will be 40 Newton. It will get reduced. Right? Okay. Let's concentrate on question number 3 then. Third question is, a body of weight 60 Newton is taken to a depth r by 4. What would be the weight of the body? Okay, this is an interesting question. And again, we have to directly make use of the formula. We are aware this is the Earth. At a point on the Earth's surface, the value of small g, we are aware it's given by gm by r square, or it is given by 4 by 3 pi r rho g. Rho is the density, isn't it? This is the center and this is the radius r. Now, at a depth x, suppose this is point B, which is at a depth x. Now at point B, the value of acceleration of gravity would be 4 by 3 pi. Now instead of r, we will write r minus x. The gravity at point B will be due to this portion, the dotted one, due to this portion, isn't it? Whose radius is r minus x. So instead of r, you will write r minus x. Density is considered to be constant throughout. It's the average density. So if you divide these two, g dash by g, what do you get? R minus x divided by r, or g dash is equal to 1 minus x by r into g. So this is the formula which you have to make use of. You need not to prove it time and again. Once the formula has been derived in the theoretical portion, while solving numericals, do use that formula directly. Right? Now coming back to question. A body of weight 16 Newton is taken to a depth of r by 4. So here x is given to be r by 4. So what would be the weight of the body? So let's see. So g dash, it will be equal to 1 minus x is r by 4. So r by 4 divided by r, it will give us 1 by 4. So it is equal to 3 by 4 of g. Am I clear, students? Now multiplying both the sides by mass of this body. Suppose the mass of this body is m. So what do you get is mg dash is equal to 3 by 4 mg. M is the mass of the body. So what I have done is I multiplied both sides of this equation by small m. So mg dash, this becomes the weight of the body. 3 by 4, this becomes the weight of the body on the earth's surface. So it is 3 by 4 of weight on the body on the earth's surface. That is 60. So what do you get? 45 Newton. So when a body which weighs 60 Newton on the earth's surface is taken to a depth r by 4, then its weight will get reduced. It will reduce to 45 Newton. And students, we are aware, with the increase in the altitude, the value of small g decreases, so the weight will keep on decreasing with the increase in the altitude. Similarly, with the increase in the depth, the value of g decreases, therefore the weight of the body also decreases. And eventually and ultimately at the center of the earth, the value of small g becomes 0, and accordingly the weight of any body at the center of the earth will be always 0. Right? So we are done with question number 3 as well. Okay, next one, fourth question. Quite interesting one. Amit buys few grams of gold at the poles as per the instruction of one of his friends. He hands over the same when he meets him at the equator. Will the friend agree with the weight of the gold bought? If not, why? It's an interesting question, right? So, for this, you should be aware. These are the poles and this is the equator. Strictly speaking, Earth is not a perfect sphere. It is ellipsoidal. So what I mean to say is that this is the radius and this is the radius of equator. Actually, RP is less than R equator. The radius of the equator, students, listen to this information very carefully. The radius of the equator is about 21 kilometer more than the radius of the poles, right? So it is quite flat. So RE is greater than RP. Now look, small g is equal to gm by r square. That is, greater the radius, lesser will be the value. Smaller the radius, greater will be the value of small g. So definitely here the radius is smaller, here the radius is larger. Therefore, g at poles would be greater than g at equator. Is it clear? There is a very small difference, but the difference does exist. So even on the Earth's surface, the value of small g is different at different places. At the poles, it is maximum. At the equator, it is minimum. And at any other place, its value will lie between g equator and g poles. Clear? So multiplying both sides by m, what do we get? mg poles is greater than mg equator. Mass, m is the mass of a body under consideration. M into g, that will give us weight. So weight of a body at poles is always greater than weight of the same body at the equator. So this is the concept to be used in this particular question. Right? So when Amit hand over the gold, a certain amount of gold to his friend at the equator, then what will happen? At the equator, the gold will weigh less. So obviously the friend will not get convinced. He will definitely have an argument with his friend. But in case Amit is able to convince his friend scientifically with this logic, then his friend might get convinced. Isn't it? So definitely at the equator, the weight of the given amount of gold will certainly decrease by a very small amount, but it will certainly be less than that of the weight of the gold at poles. Clear, students? So we have discussed the reason as well. So reason is the value of acceleration due to gravity at the poles is maximum while at the equator is minimum. So whenever a body is taken from pole to equator, then its weight slightly decreases. So students, this is an instant method of losing one's weight. If one wants to lose his weight or her weight instantly, then please do recommend him or her to go to the equator. Right? Anyway, jokes apart, we are over with this particular session. I hope you have enjoyed this session, and please do concentrate on each and every concepts involved in the theoretical portion. Right? It is only then you will be able to solve these numericals. Right? So do take very good care of yourself.